July 5, 1943, Kursk salient, Soviet Union. 200 newly built Panther tanks from the 39th Panzer Regiment, part of the elite Panzer Regiment von Lauchert, stood poised for their combat debut. Painted in fresh camouflage, their crews confident and expectant, these machines represented Germany's newest armored weapon, a tank that promised to revolutionize modern warfare. Of the 200 tanks ready that morning, 184 were operational. The rest were already in need of repair. The German High Command believed the Panther's combination of sloped armor, firepower, and speed would turn the tide in the east. Within 48 hours, only 40 Panthers remained fit for battle. Within 2 weeks, the regiment's operational strength had collapsed to just 16%. The Panther's catastrophic debut at Kursk would expose a fundamental contradiction in German engineering. A tank that was brilliant on paper, but fatally flawed in practice, a contradiction between cutting-edge design and disastrous reliability that shaped the outcome of the Second World War. The Panther was born from Germany's shock encounter with the Soviet T-34 in the summer of 1941. When German panzers rolled into Russia, their Panzer IIIs and IVs dominated early battles, until they met the T-34. Its sloped armor, wide tracks, and powerful 76mm gun made every German tank obsolete overnight. The T-34 combined simplicity and durability with devastating effectiveness. In response, the German Army's weapons department demanded a new medium tank that could defeat the T-34 and restore German superiority. 2 designs were submitted, one from Daimler-Benz and one from MAN, Maschinenfabrik Augsburg-Nürnberg. In May 1942, MAN's design was selected and production began in January 1943. The result was the Panzerkampfwagen 5, the Panther. On paper, it was revolutionary. Weighing 45 tons, the Panther sat between the lighter American Shermans at 30 tons and the heavy Tiger at 57. Its 80mm frontal armor was sloped at 55 degrees, giving it the protection equivalent of 140mm of vertical steel. The sloped armor, copied directly from the T-34, dramatically increased survivability against Allied guns. The main armament, the 75mm QBK-42 L-70 gun, was one of the most powerful weapons ever mounted on a tank at the time. Its long barrel and high muzzle velocity gave it extraordinary range and penetration. At 1,000 meters, it could pierce 120mm of armor, enough to destroy any Allied tank frontally. Even at 2,000 meters, it could knock out a Sherman before the American tank could fire effectively in return. The Panther's Maybach HL-230 engine, a 12-cylinder V-shaped gasoline engine producing 700 horsepower, was a marvel of German automotive engineering, theoretically giving the Panther excellent mobility despite its heavy armor. But beneath these impressive specifications lay the seeds of disaster. The Panther's complexity demanded manufacturing precision that wartime Germany could not sustain. Its engine required high-octane fuel, something the Reich's synthetic fuel plants could barely supply. The transmission, with 7 forward gears, was advanced but fragile. The tank's 45-ton weight overloaded nearly every component, pushing the mechanical design far beyond its limits. Within days of entering combat at Kursk, these weaknesses became impossible to ignore. Engines burst into flames, transmissions seized, final drives, the gears that transferred engine power to the tracks, shattered under strain. Tracks snapped, suspensions fractured, and fuel systems leaked. Of the 184 operational Panthers on July 5th, only 40 remained by July 7th. Not because of Soviet guns, but because of mechanical collapse. A German report filed on July 20th catalogued the failure with bureaucratic precision. 41 Panthers were operational. 85 were repairable with parts that did not exist. 16 had to be sent back to Germany for major overhaul. 56 had burned out under enemy fire, and 2 were destroyed by spontaneous engine fires. By the end of July, operational availability was just 16%. A disaster of such magnitude that even Hitler demanded an explanation. Engineers blamed the rushed production schedule. The truth was simpler. The Panther's design exceeded what Germany's resources and materials could reliably produce. The pattern seen at Kursk repeated across every front. Throughout 1943, Panthers averaged only 37% operational readiness. A battalion that should have fielded 96 tanks rarely had more than 35 ready for combat. By late 1944, availability improved to around 50%, but never reached the 80 to 90% required for sustained operations. For comparison, American Sherman units routinely maintained 70 to 80% readiness. Even when Germany concentrated its best maintenance units and resources, as during the Battle of the Bulge, Panthers broke down faster than they could be repaired. In that winter offensive, of 471 Panthers committed, 336 began the battle operational. Within a week, 1/3 were immobilized by mechanical failure alone. The core problem was simple. The Panther was supposed to be a 35-ton medium tank. By the time it entered production, additional armor and a heavier gun pushed its weight past 45 tons. Every mechanical system, engine, transmission, suspension, and final drive was overstressed. Post-war analysis by the French Army confirmed that the Panther's final drive was its weakest component, lasting only about 150 kilometers before failure. Half of the Panthers examined in Normandy showed final drive breaks from ordinary use, not combat. German wartime steel shortages only made things worse. As Allied bombing cut off access to critical alloys like molybdenum and nickel, German armor and mechanical parts degraded in quality. The result? Vital components that wore out or shattered after minimal use. Between 1943 and 1945, Germany built about 6,000 Panthers, a monumental industrial effort under constant bombardment. Yet this production achieved far less military impact than it should have. The United States, by contrast, produced over 49,000 Sherman tanks between 1942 and 1945. The Sherman, officially the M4 medium tank, was not glamorous. It was slower, its armor thinner, its gun weaker. But it was simple, reliable, and endlessly available. Its Continental radial engine, adapted from aircraft use, was rugged and easy to maintain. It consumed less fuel, rarely overheated, and could be repaired in the field with basic tools. American factories used standardized parts and assembly lines that allowed tanks to roll out at 10 times Germany's rate. A Sherman battalion could replace lost vehicles within days. A German panzer division might wait months, if replacements ever came. The Panther's supposed superiority became its downfall. It required twice as many mechanics and twice as many trucks for spare parts and recovery. A 100-kilometer road march for a Panther battalion consumed 35,000 liters of fuel, 2.5 times that of a Sherman battalion. As Germany's synthetic fuel supply dwindled to 1/10 of American production, entire panzer units were immobilized simply because there was no fuel to move them. The Panther's appetite for maintenance, spare parts, and gasoline made it a logistical nightmare that Germany's collapsing war economy could not sustain. By late 1944, the Panther had become a symbol of Germany's over-engineered futility. It inspired fear among Allied tank crews. Its long 75-millimeter gun could kill at 2 kilometers, but it could not sustain itself in prolonged campaigns. Crews learned to fear not just enemy fire, but their own machines. A minor oil leak could become an inferno. A broken gear meant abandonment under fire. German soldiers who once boasted of their technical superiority began to dread the complexity of their own vehicles. The psychological toll was immense. Tank commanders hesitated to push their machines, fearing mechanical breakdown more than combat loss. The Panther, meant to lead German offensives, became instead a static defensive weapon, powerful, but trapped by its own fragility. The contrast with American doctrine was absolute. The U.S. Army's design philosophy favored simplicity, standardization, and logistics over technical perfection. The Sherman was not the best tank on the battlefield, but it was the best tank for global war. It could be built fast, shipped easily, repaired anywhere, and manned by crews trained in weeks. Its parts were interchangeable, its maintenance procedures simple, its supply chains robust. On the battlefield, what mattered was not which tank had thicker armor or a longer gun barrel, but which one was actually running, fueled, and ready when the fighting started. The Sherman was always ready. The Panther rarely was. Even British and French evaluations after the war confirmed this reality. French tank regiments operating captured Panthers after 1945 concluded that their mechanical life was only 150 kilometers before major repair. British engineers who tested a Panther in 1944 noted the same issues with the interleaved road wheels that froze solid in winter mud, immobilizing the tank overnight. Changing a single inner road wheel could take an entire day. The suspension that looked ingenious in a German design bureau became a nightmare in Russian mud or the snows of the Ardennes. The Panther's maintenance burden was measured not just in man-hours, but in lost battles. Hitler's personal interference compounded every problem. He demanded thicker armor, heavier guns, and faster production simultaneously. Engineers protested that testing was incomplete, but production continued anyway. The Panther went to war without durability trials, without field testing, and without adequate spare parts. The result at Kursk was inevitable. What should have been a weapon of armored dominance became an industrial tragedy. A tank that destroyed itself faster than the enemy could. The Panther remains one of the most iconic tanks of World War II. Admired for its beauty, power, and innovation. Yet, its legacy is one of failure. A monument to the limits of engineering divorced from strategy. In the end, the Panther's 6,000 units achieved less than the Sherman's 49,000 because numbers, reliability, and logistics, not perfection, decide wars. The German pursuit of technical excellence produced a masterpiece that could not be maintained, while Allied pragmatism produced a workhorse that could not be stopped. The Panther was a triumph of engineering and a failure of understanding. The Sherman was a triumph of production and practicality. And it won the war.